This unit we're talking about something called logarithms, which frankly sound kind of scary and people start freaking out about them. But really all a logarithm is a power. So a logarithm can ask the question, what power of 3 gives you 9? Well, that's pretty easy to answer. It's 2. What power of 3 gives you 3? 1. What power of 3 gives you 1 over 3? -1. What power of 3 gives you the square root of 3? 1/2. What power of 3 gives you -3? Can't do that. And what power of 3 gives you 1? 0. What we've really been doing was a logarithm. So that first question, what power of 3 gives you 9, is log base 3 of 9. It's asking the question, what power of your base gives you that thing, and that's called your argument. So log base b of x means, hey, what power of b gives you x? So if I want to find some exact values, this is asking, what power of 5 gives you 25? 2. What power of 2 gives you 32? Well, we have 2 times 2 times 2 is 8, times 2 is 16, times 2 is 32, so that's 5. What power of 3 gives you 27? 3. What power of 5 gives you 1 over 25? So when I see it make that fraction, I know it's going to be a negative. And then I think about how do I go from 5 to 25? I'm going to square. So my answer would be -2. What power of 5 gives you 1? 0. What power of 5 gives you 5 to the m? It's just m. It's almost like the base and that part of your argument are canceling. What power of 2 gives you 64? Well, 2 to the 5th is 32, so 2 to the 6th is 64. What power of 8 is 64? 2. What power of 2 gives you the cube root of 2? That's 1/3. In case you didn't remember, when I do something like a cube root, that's like raising it to the 1/3 power. What power of 2 gives you 1 over 8? The fraction means it's going to be a negative, and 2 to the 3rd gives me 8. What power of 2 gives you 2? 1. What power of 2 gives you 1? 0. And that's it for that section. By the way, just something that's a pet peeve. The argument is not an exponent, so your base is really teeny tiny, so if I'm doing 2, it's right here, it's small, right next to the g, and then in line with where you wrote log is whatever your argument is, so say it's 8. So that's big. It's not like this, where that's the exponent, okay? Just FYI. Okay, now we got some weird ones. So log base 2 of 2 to the 4th is going to be 4. Log base 2 of 2 to the 3j is 3j. What power of 2 gives you 7 squared? That's not going to give me a specific answer. We could get kind of close to it. So that's saying 249 is going to be 7 squared. So it'll be somewhere between 5 and 6. Log base 2 of 2 to the m cubed is going to be just m cubed. What power of 2 gives you -2? You can't do. What power of -2 gives you +2? You can't do. What power of 0 gives you 2? Can't do that one. And what power of 2 gives you 0? Sorry, you can't do. So B, your base, needs to be a positive number, so greater than 0. And your argument also needs to be greater than or equal to 0. You can get something that results in 0, or sorry, no, also needs to be greater than 0, sorry. Hello. We can get 1. Okay, and log base b of b to the x is just x, whatever your exponent was there. The other thing we need is to be able to go between exponential notation and logarithmic notation. And some people, they like to use this little swirl thing, and some of you have seen the swirl thing, so I'm going to teach you the swirl thing, even though I'm kind of morally opposed to the swirl thing, but we're gonna go with it. So you want to start with your base, you go around to the other side, and then you end at your exponent. So log base 4 of 16 equals 2. What power of 4 gives you 16? 2 is how you can check. Log base A of C equals B. Log base K of P equals M. So your base should always be the same. So I have a base of A, and then, I hate to say it this way, but they do just kind of swap places the other two pieces of your form. Okay, so this one, as I don't get killed, hopefully, by the math police, is 7 squared equals 49. Swirl. A to the C equals B. Loop-de-loo. 2 to the Z equals X. And the last thing to deal with is, oh no, my logarithm has no base. So sometimes you'll see something like this, log 100, or natural log. So log 100, if you don't see a base, it's considered to be base 10, because we operate in something called a base 10 system, which is why we have all the nice things, like when I multiply by 10, it adds a 0, all that kind of stuff. So if you don't see a base, if it says log 100, then you can add the 10, and it means what power of 10 is 100, and my answer would be 2. We could do all sorts of problems with those. The other thing is something called a natural log, and this is one of those mathematical numbers that comes up all the time, just naturally in nature. Haha, natural log. Called E. It's special just like pi, and it is so special that it gets its own base, which is natural log, and I write it with the cursive EL, otherwise it looks like 1N or something like that. Now, why does the L come before the N? It came from French, and they put the descriptor after the noun instead of before like we do. So anyway, that's the same thing as saying log base E of X. So if I say natural log of E squared, that's the same thing as saying log base E of E squared, which we talked about on the previous slide, is just going to reduce to 2. Please don't read it as ln, it's natural log. Please and thank you. That's it.